Hello everybody. Once again I am here with you for the first session and the first unit, which is to be related with the our paper mechanics and properties of matter, and the unit number 1, that is the mechanics, and what exactly it contains or what meaning to be as an mechanics, that we will see in detail. And how this mechanics is the one of the branch of the physics which deals with the motion moving bodies and bigger bodies that we will see in this part. Now first thing, what means to be as an mechanics, and that is what the introductory section is to be there. Basically classical mechanics and the quantum mechanics is the two parts, somehow we can say related with this mechanics are to be there. But basically mechanics is nothing but it is the branch of physics which deals with the physical objects in the motion and at rest under the influence of external and the internal interactions. And internal interactions, in that sense, the force of attractions or repulsions, that all things are to be there. And basically this mechanics is nothing but to be as an called to be as an your classical mechanics. But this total classical mechanics, either you will call, or the mechanics in general you will call, it is totally based with the Newton's laws, and that's how it is to be the very much important factor for this mechanics. And that's why this branch is nothing but to be related with the physics and which deals with the physical objects in the motion. That is, if you will see in the upside, that is in the sky, there are number of objects which are in the bigger size and they are moving. And somehow you can see in the astrophysics, that is to be the what in detail you can study. But basically the mechanics is to be related with the motion of the bodies or the objects in the motion, again at rest. Either it is at the rest and but under the influence of that is to be external as well as the internal forces are to be there, or interactions we can say in simply. And all these things are related with your Newton's laws of the motions are to be there. And somehow due to this mechanics or the classical mechanics is totally based with the Newton's laws of mechanics, and that's why this classical mechanics is also called as a Newtonian mechanics or vectorial mechanics is to be there. For the Newtonian mechanics, we are aware about that this is to be based with this mechanics is to be totally based with this Newton's laws of motion. But why it is called to be as an vectorial mechanics? Because whenever we take the two bodies and if you draw a single line in direction and the magnitudes are to be there, there is a vector we can say from one to another. And if I want to find out the distances in between them or whatever it may be, if that line with the magnitude and the direction and the magnitude, that gives you nothing but to be a vector, we can define as a vector, and the scalar quantities are to be there. And that is how it is comes to be the word as a vectorial mechanics. Again, it is very much clear in the definition, that is to be the classical mechanics is successfully deals with the whatever be the motion of the relative massive particles. That's, if you, I already told you in the sky, that is the objects are very much bigger and the massive bodies are to be there, and at least it is to be slow moving objects are to be there. So classical mechanics is dealing with the bigger and the massive objects which are moving in the universe, or you can say in the sky, or in simple way, the objects which are to be as in massive, having the bigger size, and they are regularly in the motion. This mechanics talks about them that bodies. So understanding this part, that is meaning to be as in mechanics, let's start for the first part, which is to be as an whatever be the our three laws are to be there, that is called to be as an Newton's laws of motions are to be there. And in this case, the first law, or that is to be the Newton's laws of motion, in which the first law, which is to be again related with us, that is called to be as an inertia or law of inertia. Basically wherever to be we are discussing for this case, that is to be as an inertia, all these no doubt three laws or the Newton's laws of motions we already studied at the 12th standard, but in detail or somehow how they are correlated with the whatever the little bit equation oriented part that we will also see in detail. Basically, inertia is nothing but to be a body continuously in the state of rest or the uniform motion. It is going to be continuously in its motion or the rest unless and until it is disturbed by the some external force, or that is somehow due to the influence of the external force, the whatever be the either it is in the rest or either in the it is in the slow motion, that will be going to be disturbed only and only due to the external force. In simple way, एखादा ऑब्जेक्ट एका जागेपासून दुसऱ्या जागी जर न्यायचा असेल, I have to use some external force, then and then only the thing is going to be from one place to another place, otherwise it will remain as it is. Again, इफ यू आर मुव्हिंग, सायकल जर स्लो चालवत आहेत आणि तुम्ही जोपर्यंत स्पीड एक्सटर्नल फोर्स जोपर्यंत एक्स्ट्रा वापरणार नाही तोपर्यंत त्याची स्पीड वाढणार नाही. अँड दॅट इज सम हाऊ इट इज टोटली डिपेंडिंग ऑन एक्सटर्नल इन्फ्लुएन्स ऑफ द फोर्स. म्हणजे जोपर्यंत एक्सटर्नल फोर्स आपण अप्लाय करणार नाही, ती बॉडी त्याची जी काही गती असेल किंवा ती रेस्टवर असेल तर ती त्याची पोझिशन चेंज करणार नाही. अँड दॅट इज नथिंग बट टू बी अ प्रॉपर्टी ऑफ नॉट चेंजिंग इट सेल्फ अवर सेल्फ. दॅट इज नथिंग बट टू बी अ इनर्शिया. इन सिम्पल वे, सकाळी जर आपल्याला उठवलं तर आपल्याला खूप हलवून उठवावं लागतं, स्वतःहून आपण उठत नाही. सम एक्सटर्नल फोर्स आपल्याला जेव्हा लावले जाते त्यावेळेस आपण जागी होतो. सम हाऊ इट इज टू बी ॲज अन inertia is to be 100% in our body in the morning or at the sleeping stage, we can say. So this is simple law of the first law of the Newton's law of motion, and that is nothing but to be a law of inertia is to be there, and this property is nothing but to be called as an inertia. So this is somehow simply we can say the whatever be the inertia meaning to be as an your the property of the body that cannot change its states of rest or uniform motion is called to be as an inertia. So this is the first law or the law of inertia, we can say. Secondly, moving a little bit forward for the second law of the motion, and that is the Newton's law of motion, second law, and which is to be related with the force, and that is simply the rate of change of momentum of a body is directly proportional to the external force acting on it. So this was the simply rectified case what you have studied at the 12th standard, but what exactly meaning to be as an rate of change of momentum? So understand the momentum first, you have to know what property meaning to be as in momentum. Momentum म्हणजे काय? That is mass into velocity. एव्हरी बॉडी इज हॅव्हिंग द मोमेंटम. तुम्हाला मला प्रत्येकाला एक मोमेंटम आहे. सगळेजण एकाच स्पीडने पळत नाहीत, कोणी कमी कोणी कमी जास्त. सिम्पल वेमध्ये जर बघायचं राहिलं तर जाड माणूस असेल तर तो जास्त जोरात फास्ट पळत नाही, कारण ते जोर असते त्याचं बल्की मास. आणि तो जर लुकडा असेल तर तो फास्ट पळू शकतो, कारण ते जोर असते मास कमी. मग त्या ठिकाणी त्याची पळण्याची स्पीड दॅट इज इट्स वेलॉसिटी, त्या पर्सनची वेलॉसिटी, आणि जाड माणसाची वेलॉसिटी इट इज अगेन टू बी डिफरंट. अँड मास त्याचं स्वतःचं आणि त्याची पळण्याची स्पीड दॅट कॉज टू द momentum, mass into velocity is to be there, and that is somehow this momentum is to be very much important. The rate of change of momentum of a body is directly proportional to the external force acting on it. That is to be the case. आता आपण जेव्हा क्लासिकल मेकॅनिक्समध्ये बघत आहोत की वॉट एव्हर बी दी सेलेस्टियल वॉट एव्हर बी दी बॉडीज आर टू बी व्हेरी मॅसिव्ह, हॅव्हिंग द larger mass, and if they are going to be moving they are having the momentum itself, and the every object is having the different mass, and due to that every object having the different momentum, and due to that the whatever be the external forces are going to be acting according to that, their momentum is going to be the rate of change of momentum of a body, which is going to be directly proportional to the external force acting on it. जेवढं एक्सटर्नल फोर्स त्याच्यावर लावलेलं आहे त्याच्यावर डिपेंडंट करते त्याचं रेट ऑफ चेंज ऑफ मोमेंटम इज टू बी देअर, अँड दॅट इज somehow the whatever be the influence of under the which the velocity of a particularly particle changes is called to be as, and this quantity is nothing but to be a force. आणि हे जे काय एक्सटर्नल म्हणजे इन्फ्लुएन्स म्हणजे ज्या फोर्समुळे जे पर्टिक्युलरली ज्या प्रॉपर्टीमुळे ह्याच्यामध्ये वेलॉसिटीमध्ये जो चेंज व्हायला दॅट इज टू बी ॲज अँड कॉल टू बी ॲज अँड फोर्स, सो इट इज कॉल टू बी ॲज अँड सेकंड लॉ. and which is law of force, again it can be said, or it can be also called the second law of Newton's law of motion is to be there. And suppose in case if suppose the F be the force acting on a particle of momentum p, जर स्मॉल p हे जर मोमेंटम असेल आणि फोर्स हे जर F कॅपिटल ऍक्टिंग त्याच्यावर असेल, तर वी कॅन इक्वेशन पॉईंट ऑफ व्ह्यूनी ह्या सेकंड लॉला जर रिप्रेझेंट करायचं असेल, तर F इज इक्वल टू डी पी बाय डी टी, दॅट इज रेट ऑफ चेंज ऑफ डी डी टी ऑफ पी, स्मॉल p, म्हणजे रेट ऑफ चेंज ऑफ डी डी टी मीन्स रेट ऑफ चेंज ऑफ मोमेंटम is directly proportional to the whatever be the external influenced force is to be there, and that is somehow it is called to be as an capital F is equal to dp small p upon dt is to be there, where if suppose the v is the velocity considered, if we consider small v is to be the velocity of a body that is to be there, and m be the mass, small m be the mass of the body, then the momentum is defined no doubt m into v, and somehow we can say it is to be as an simply again I can write this F is equal to d dt of p, that means d dt of mv I can write. So this is somehow in a simple way I can also write this relationship for the law of force, or we can say the for the Newton's law of motion, second law of motion, that for the force we can define as a F is equal to d dt of mv. Now in this case, where the basically if you look at this case where to be as an law of force is to be there, p is nothing but to be, or p is here considered as a momentum, and that is nothing but to be mass into velocity is to be there. So it is to be written here m into v is to be there, and in that case I already told you F is nothing but to be written as a d dt of mv. But as either I am here or running, I am reaching there, mass is not going to be changing, my mass will be remain as it is, so m is going to be the constant one, so coming outside, but velocity is going to be the different, and that's why it is called to be as an, it is m into dv by dt. But what is dv by dt is to be there, rate of change of velocity is nothing but to be d dt of v is nothing but to be acceleration, and due to that displacement with respect to time is nothing but to be your velocity part, but velocity with respect to time, that is nothing but to be giving you the acceleration part, and that's why this quantity as an F is equal to, I can write in this fashion, that is F is equal to ma, that is mass into acceleration, and that's why this is to be somehow, this law of force is also called to be as an ma, that is to be as an mass into acceleration is to be there. This is what the our second law, or the Newton's second law, or you can say the law of force is to be there. Now moving forward for the third law, which is to be Newton's law of motion. In this case, in simple way, in day-to-day life also we can apply this for the law of action and the reaction is to be there. This is what the third law, एखाद्याने एखादी गालाखाली आपल्या ठेवून दिली तर आपण लगेच त्याला रिप्लिकेशन मध्ये रिप्लाय देऊन टाकतो, that is action and reaction is to be there. So this is what somehow the simple law of action and reaction, to every action there is equal and opposite reaction is to be there, and this is somehow very simple law of action and reaction we can say. In this case this meanings to be, there are two bodies, दोन bodies आहेत, त्या दोन bodies म्हणजे interaction mutually is to be given as a f is f of 1 2 is equal to minus of f 2 1. याच्यामध्ये म्हणण्याचा उद्देश काय, this is what the when we are talking about the two bodies, here is to be the one body and here it is to be the another body, and when the both bodies, this is 1 and this is 2, now on this f first body, the whatever be the force or the acting due to the second, that is to be the force on the first body due to the second, if the both bodies are coming nearer or having some distances are to be there, this first body having some action or the force that is on the this first body due to the second, it is nothing but to be whatever be the equal to negative, or that is somehow opposite to whatever be the second body as whatever be the force due to the फर्स्ट बॉडी. म्हणजे एकमेकांच्या ऑपोजिट डायरेक्शनमध्ये असते. या फर्स्ट बॉडीवर सेकंड बॉडीचा जो काही फोर्स आहे तो हा इक्वल टू आहे इन अपोजिट डायरेक्शनमध्ये सेकंड बॉडीवरचा फर्स्ट बॉडीचा असणारा फोर्स दॅट इज टू बी देअर when they are coming closer to the field of area where the force is going to be experienced. And this is somehow the force on the first body due to the second is nothing but to be the force on the second body ड्यू टू द फर्स्ट. म्हणून इथं लिहिताना हे जे काही रिलेशनशिप लिहिलेली आहे या इक्वेशन वनचा अर्थ असा आहे, फोर्स ऑफ अ फर्स्ट बॉडी ड्यू टू द सेकंड अँड विच इज इक्वल टू मायनस ऑफ force of second body due to the first is to be there, and this is somehow equal but in opposite directions are to be there. And that is how the both forces of attractions are to be there, which is coming out towards the, it is in the opposite directions are to be there. And whatever be the this f12, the rate of change of momentum of the first body is nothing but to be, again to be, we can, wherever the force is to be there, we can write this relationship in this force, whatever the definition in the second law we have seen. And in due to this relationship we are aware about that how the second law is the force of second law of Newton's second law of motion, that is to be the, we can say, the law of force, we can say it is to be given with rate of change of momentum is directly proportional to whatever external force is to be there. And somehow we can write this f of 1 2 is nothing but to be ddt of m1 v1. म्हणजे ही जर फर्स्ट बॉडी असेल तर हिचं काहीतरी मास आहे, मग हिला ह्या फर्स्ट बॉडीच्या जे काही मास आहे त्याला आपण m1 म्हणलं, ह्याची जी काही व्हेलॉसिटी आहे त्याला आपण v1 कन्सिडर केलं. ही दुसरी बॉडी आहे, या दुसऱ्या बॉडीचं काहीतरी मास असणार आहे, त्याचं मास आपण m2 कन्सिडर केलं आणि त्याची व्हेलॉसिटी v2 आहे. मग ह्यांचं एकमेकांवरचं असणारी फोर्सेस ऑफ अट्रॅक्शन किंवा रिपल्शन काटे व्हॉट एव्हर इट मे बी इन दिस वे इज टू बी देअर. So negative direction is either it is coming towards or going away from this. That is what the negative thing is to be written. So f12 is nothing but to be ddt of m1 v1, and that is somehow again mass is not going to be changing, that's why it is going to be the constant, and m1 dv1 upon dt we can write in the same way. Second body lapan f21 I can write in the same fashion, that is f21 is equal to m2 dv2 upon dt is to be there. But putting these relationships in equation number 1, both are going to be equal. So when these parts, that is f12 is equal to minus of f21, that is why I am writing this m1 dv1 by dt is equal to minus of m2 into dv2 upon dt is to be there. So this relationship we can write in this fashion as far as we are aware of it, that mass into acceleration part is to be there. So moving forward, again putting these relationships in detail, as we are aware about that m into here the m is going to be missed, and here it is compulsorily m is to be there. M into dv1 by dt is nothing but to be called to be as an a1, and here m into dv2 by dt is nothing but to be a2 is to be there. Here m is going to be missing because mass into dv by dt is nothing but to be acceleration part is to be there, because rate of change of velocity is nothing but to be acceleration is to be there, as which is related for the first body, that's why it is to be a1, and this dv2 is related with the second body, that's why acceleration for the second body is to be there. Then with this case we can write m a1 is equal to m a2 is to be there. So understanding or to knowing the some body's mass, and if suppose two bodies are closer or nearer to each other, in that case if we know the mass of the first body, we know the acceleration of the both the bodies, then we can find out the mass of the second body. So using this way we can also find the masses of the different bodies, and that's why this somehow Newton's third law defines masses and of the different objects of the in the universe are to be there. So this is what the Newton's law of motions, the third law is to be there, which is called to be law of action and reaction is to be there. So these are the very basic laws which we already studied at the 12th standard, but it is again for to revise what is to be there and little bit in detail. So thank you for the joining this session, and be at home and be safe. Thank you.